All right, so you've been practicing parallel lines and transversals, correct? We did a couple IXLs that helped you with those. We're going to add some postulates and theorems that give you ways to solve for measurements on parallel lines with transversals. So if you wrote it down, you should have written it down. Postulate 15. Which is talking about corresponding angles. And it tells you if two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. Do you guys remember what corresponding angles are? Basically, when you look at the parallel lines of the transversal, corresponding angles are the angles that are in the same side of the transversal, same spot of the parallel line. So for example, 2 and 6 here, and all postulate 15 is proving that they're equal to each other, they're congruent. So if I know the measure of angle 2, I know the measure of angle 6. Okay? That's the short version of what that means. So we're going to look at example 1. Put this in your journals. We have two parallel lines cut by a transversal. And remember, you can tell they're parallel by these little triangles that they put on them. All right, the measure of 3 of the numbered angles is 120 degrees. We're going to identify the angles and explain our reasoning. So when it says explain your reasoning, you're just telling me what postulate theorem proves it. So, first of all, you see the measure of angle 120 is at this angle. What do you automatically know is going to be 120 compared to this? 5. Yes, the measure of angle 5, so write this down, equals 120. And why?
Corresponding
angles postulate, or you can just put postulate 15. Good. Okay, what's another one?
8.
Why 8?
Alternate exterior angles theorem.
We haven't gone over that theorem yet, so think of another theorem. Vertical angles. Very good, Gabe. Measure of angle 8 is a vertical angle to 5, right? Vertical angles theorem. All right, is there another one?
4.
Yep, because it's the other vertical angle. So you can write that, it's the same reason. You could have also said 4 and 8 are corresponding angles. So once you found out that one was a vertical angle, you found out that the other is a vertical. I was like, who's this child all bundled up? I can't tell. That's Ruby. All right, so they told us that we had 3 angles that are 120. Do we have 3 angles now?
Mm-hmm.
Yep. So you have solved it. Good job. All right, let's look at the other theorems. All right, so these should be in your journals. Let's talk about them. Okay, alternate interior angle theorem. If 2 parallel lines, always are cut by the transversal, here's our 2 parallel lines, here's our transversal, then the alternate interior angles, so the first word alternate talks about the transversal. They are on opposite sides of the transversal. The interior talks about the parallel lines. They are on the inside of the 2 parallel lines. If all of those things happen, then we know that those 2 angles are congruent, which means they have the same measurement, right? Good. Here's another one, alternate exterior angles. So again, alternate's talking about the transversal. They're on the opposite sides of the transversal. And exterior means they're both on the outside of the parallel lines. And again, they are congruent, so they equal each other. And then the last one is theorem 3.3, consecutive interior. Consecutive means when you're looking at the transversal, they're on the same side. And then these two are interior. But what's the rule on these ones? Supplementary means add to 180. So consecutive interior measurements equal 180 degrees. Okay? We'll be able to use these to solve for the measures of angles. This is why I have you write them in your journals, because there's so many postulates and theorems, it's hard to memorize. So let's look at example 2. Put this in your journals. All right, we have two parallel lines. Cut by a transversal. This is angle 4. This measurement is 115 degrees. This measurement, we don't know, it's x plus 5 degrees. Okay, this is line A and line B. All right, they want you to find the value of x. So how do we work our way to that? Looking at the information we have, what measurements can we go ahead and write in here? Yeah, this measure of angle 4 is 115 degrees. Why do we know that? Vertical angle theorem, very good. So if I know that, then is there a way for me to solve for x now? Yes. How do I solve for x? Yes, so we know consecutive interior angles do what? So I can say 115 plus x plus 5 equals 180 degrees. And now I can just solve. All right, so we have a plus sign here, so we can just drop the parentheses. So I have 115 plus 5, which is 120 plus x equals 180. So now subtract the 120. X equals, what's 180 minus 120? So they asked us to solve for x. So x equals what? Now, some of these equations, after you've solved for x, are going to actually ask you what's the measurement of this angle. So make sure you know what question they're asking you, because the measurement of this angle is actually 65, right? Degrees. But in this case, they only asked for x. Just making sure you're aware of that. Good. All right, let's example 3. Ooh, a proof. Here we go. We are going to prove that two parallel lines are cut by a if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So let me draw my lines on here real quick, because I am super visual. So we have two parallel lines. Alternate interior is what we're looking at. So if I use the angle number 3 here, oh wait, I need to label these. This is P and Q. Doing a proof, we have statement and reasons. What's the first thing we always do? Yep. What is the only thing we know so far? Yep. P is parallel to Q. Very good. All right, so I have 1 and 2 are alternate interior angles, correct? But I'm going to compare using angle 3 so that I can walk my way to why we know they're congruent. What are 1 and 3? What kind of angles are those? It's a C word, yep. They're corresponding. Angle 1 and angle 3 are corresponding angles postulate. Gay was giving me the answer to the next one. What is angle 3 and angle 2? These two right here. Angle 3 and angle 2. Yep. Vertical angles. Very good. You will use the vertical angles theorem so many times. Now look here. I have a 3 here and a 3 here. So I can say angle 1 is congruent to angle 2. And what did I do?
Substitute.
Didn't substitute. It's the other one. Transitive. Very good. Okay, so you just did a mini proof. Good job. The cool thing is, we already know that angle 1 and 2 because of postulate. Which postulate is it? Theorem 3.1. Yep. So all we did was prove theorem 3.1. Let's look at example 4. I like this picture. All right, example 4. This is a real life problem. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 equals 40 degrees. What is the measure of angle 1? Okay, so I have two parallel lines, don't I? And then it's that's cut by the transversal. And they want to know if I'm looking at 2, oh, that one's hard to see, 2 compared to 1, what kind of angles are those?
Alternate interior.
Yes, they're alternate interior, right? So, what's the measure of angle 1?
40.
Because of,
Alternate interior.
yeah, what's that theorem? Theorem 3.1. I mean, you can write alternate angles theorem if you want, but I'm going to go TH 3.1. Any questions?
No.
Good. All right, so you're doing, oh, you don't have an IXL, so you're doing numbers 4 through 19. Woo, not 119. And 27 through 32, and that is your only assignment.